Hello, Margaret! Welcome to our life!
Are you sad? Are you hurt?
Are you lost?
Are you lonely? Worry no more. You are at the right channel.
Welcome to Excuses!
Welcome back, Marka X. We are now on the third and last part of our lesson for week 4, and that is all about geometric series. And for that, let me congratulate you for doing a great job so far with your lessons. You deserve a tap on the back. What's in? Are you ready? Let's go. Let us insert terms between two given terms. For number 1, that is inserting two terms between 3 and 81. So the answer should be 9 and 27. So what's the common ratio? That is 3. What about for number 2? The terms are 2 and 32, and we're going to insert 3 terms. The answers, that should be 4, 8, and 16. And the common ratio is obviously 2. And lastly, for number 3, the terms are 212.5. Inserting 3 terms, that gives us 100, 50, and 25. Here, the common ratio is 1/2. Pretty much easy, right? Well done! What's new? For this part, we are going to have an activity to give examples on finding the sum of the terms of a geometric series. So here we go. Let's check your skill in adding numbers. Well, want something? And please answer the following questions below. Number 1. What is the sum of the first 5 terms given geometric sequence 5, 15, 45, 135, and 405? The answer, 605. What about for number 2? What is the sum of the first 3 terms given the geometric sequence 1/3, 1/9, 1/27, 1/81, and 1/243? The answer, 13/27. Number 3. What is the sum of the first 6 terms given geometric sequence 4, -4, and so on? The answer, 0. Number 4. Consider the infinite geometric sequence 81, 27, 9, 3, 1, and so on. What is the sum of the first 5 terms? The answer, 121. And for number 5, what is the sum of the first 7 terms given geometric sequence 4, -4, 4, and so on? The answer, that is 4. To ensure your understanding for this week's lesson, we are going to give more examples. And here we are. What is it? Let's go for the discussion part. To find the sum of a finite geometric sequence, take note of these 3 terms. The first term, a sub 1. Second, how many terms to add? That is our n. And third, the common ratio. Substitute n, a sub 1, and r values into the formula and simplify to find the sum. We use the formula s sub n equals a sub 1 times 1 minus r to the exponent n all over 1 minus r. And r should not be equal to 1. In finding for the sum of a finite geometric sequence, aside from using this formula when your r is not equal to 1, we can also make use of the shortcut formulas given the following considerations. Now, if your common ratio is a positive 1, then we can make use of this. S sub n is equal to n times the first term. If your common ratio is -1 and your n is even, then the sum is automatically 0. And lastly, if your common ratio is still -1 and this time your n is an odd number, then the sum is the first term. Let's proceed with our first example. Here we're going to find the sum of the first 9 terms of the geometric sequence with the terms 9, 36, 144, and 576, and so on. Now let's also know or identify what is given. First, we are looking for the sum of the first 9 terms. Now, our first term is 9. Our number of terms is also 9. And for the common ratio, that is 4. How do you get 4? Well, picking any 2 consecutive terms, here our first term is 9 and our second term is 36. Getting the ratio, 36 divided by 9, that gives you 4. And since your common ratio is greater than 1, then this is the formula to use. That is S sub n is equal to a sub 1 times 1 minus r to the exponent n all over 1 minus r. So this time, we can now proceed with our solution. So that is S sub 9 equals, the first term is 9 times 1 minus, our common ratio is 4, and then n here again is 9 over 1 minus 4. Okay, now allow me to copy, equals 9 times 1 minus, okay, now let's try to expand. What is 4 to the exponent 9? Now get your calculators, that will give you 262,144. And then over 1 minus 4 is a negative 3. Now let me copy it here. S sub 9 is equal to 9 times, now we subtract 1 minus 262,144, and that will give you negative 262,143 over negative 3. Now let's do the operation. So here you will have an answer of 786,429. And that's for the sum of the first 9 terms of this geometric sequence. Again, that is 786,429. Moving on to our second example. What is the sum of the first 11 terms of 8, 8, 8, 8, and so on? Let's identify first what is given. So we are solving for the sum of the first 11 terms of this geometric sequence. Now, what is our first term? Well, obviously, that is 8. Our number of terms is 11. That's the number of terms to add. And our common ratio here is 1. Why? Well, picking any 2 consecutive terms and getting the ratio. Let's say the second term is 8, the first term is 8. 8 divided by 8, that gives you 1. And with this, your common ratio is equal to 1. So this is the formula to use. S sub n is equal to n times a sub 1. So let me show you. That is S sub 11 is equal to, your n here is 11, times your first term is 8. So that gives you 88. And that's it. Pretty much simple, right? So the sum of the first 11 terms of this geometric sequence is 88. Try to look at example number 3. What is the sum of the first 8 terms of 3, negative 3, 3, negative 3, and so on? So let's identify the given. First, we are going to solve for the 8 terms of the sequence, right? The first term here is positive 3. Our n is 8 and the common ratio is negative 1. Why? Let's say we have negative 3 divided by 3 and that's negative 1. Can you still remember the shortcut formula for this? That is S sub n equals 0. So the answer is automatically 0? Yes. Since your common ratio here is negative 1 and your n is even, so that should be 0. Well, I have to show you so that you will understand why. So here, that is getting the sum of the first 8 terms, so that is S sub 8 is equal to. Now let me show you. Let's add manually the first 8 terms of this sequence. That is 3 plus negative 3 plus 3 plus negative 3 plus 3 plus negative 3 plus 3 plus negative 3. And then let's do the operation. This will give you 0 this is 0, this is 0, and this is 0. So that's it. Our sum is 0. So again, remember that if your common ratio is a negative and your number of terms is even, then the sum is 0. Example number 4, this is pretty much similar with the previous example. Here, we are going to get the sum of the first 7 terms of this sequence. So, again, we are solving for the sum of the first 7 terms. The first term here is positive 3. The number of terms is 7, and our common ratio is still negative 1. So, the shortcut formula for this is that should be S of n is equal to, the answer is your first term. So this is only used if your common ratio is negative 1 and your n is an odd number. Now let me show you how do we come up with the first term as your answer. So that is, again, S sub 7 is equal to, let's add manually the first 7 terms of the sequence. That is 3 plus negative 3 plus 3 plus negative 3 plus 3 plus negative 3 plus 3. So we have here the 7 terms, first 7 terms. Now let's do the operation. This becomes 0, this is 0, and this is 0. So the remaining number is 3, which of course is the first term of this sequence, right? So here we go, and that's our answer for the sum of the first 7 terms.
Meanwhile, for infinite symmetric sequence, it has no last term. If we can get the sum of the infinite symmetric sequence, we call it sum to infinity. But there are cases that we cannot find the sum of infinite symmetric sequence. So we must remember the following. If your common ratio is greater than negative 1 and less than 1, then the sum is equal to the first term all over 1 minus r. But if your common ratio is greater than 1 or equal to 1, and the common ratio is less than or equal to negative 1, then it has no sum.
For infinite symmetric sequence, here's an additional example. Number 1. Consider the infinite symmetric sequence 1, 1/2, 1/4, 1/8. Find the sum if possible. Now first, let's solve for the common ratio. Let's make use of the first and the second term of the sequence. So we have a sub 2 divided by a sub 1, that is 1/2 divided by 1, and that gives you 1/2. So for this symmetric sequence, the common ratio is 1/2, which is, it is greater than negative 1 and less than positive 1. So the given infinite symmetric sequence has a sum. To solve for the sum, this is the formula to use. That is, S of n is equal to a sub 1 over 1 minus r. Then let's substitute what is given. So that is, S is equal to, our first term is 1 over 1 minus the common ratio is 1/2. That will give us 1 divided by 1/2. Or you will have 1 times the reciprocal of 1/2 is 2 over 1. And therefore, the sum is 2. For our second example, let's find the sum of infinity 1 square root of 2, 2, 2 square root of 2, and so on, if it is possible. Let's solve for the common ratio. That is, divide the second term by the first term. So we have square root of 2 divided by 1. And we have our common ratio square root of 2. So since our common ratio is square root of 2 and it is greater than 1, then it has no sum. And we are finally done with our week 4's lesson. Congratulations and thank you for your continued
If you
support.
find the lesson confusing, feel free to hit the replay button. Replay! 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 Replay!